This item of the prerequisites to network simplex is a little hidden item, and we'll make use of some of the things we've already talked about. So we're talking about the hidden dependence in networks. So let's take a network, much like the ones we've drawn so far, and we'll have something like this. A little bit messy here. Okay, so now if we need to convert this to a linear program, we would have as many equations as there are nodes. For every node, there would be a conservation of flow. So let's say that there is 60 units flowing in here, and then must be 60 units out here, or there could be outflows in between, but let's say that's the case. So 60 plus coming in and a 60 extraction from there. And then it has to, there's minimum and maximum and cost information labels for each of the arcs. And we have to decide what is the optimum route to take. So if we convert this to a linear program like we did some time ago, we would have 1, 2, 3, 4, 5, 6, 7, 8 nodes, and at each node there would be a constraint of conservation of flow. So we would have 8 constraints. And now with what we learned about basic and non-basic variables with a new definition, recognizing that each of these has a lower bound and an upper bound and a cost. So we have all these lower and upper bounds, but those are going to be dealt with specially. We have a definition of basic variables and non-basic variables, meaning non-basic that they're stuck at their upper or lower bound, and basic is they're hovering in between. So how many basic variables would there be? Well, there would be as many as there are nodes. So 3, 7, 8. So we would conclude from here that there would be 8 basic variables. And how many arcs are there? 2, 4, 5, 6, 7, 8, 9, 10. And they would be, therefore, that would imply 2 non-basic variables. Well, there is something hidden in here. And let's illustrate that. What is really the truth is not that it's 8, but there will be 7 and 3. And we will tell you why. Let's illustrate that with a... let's draw a simple network of just 3 arcs. Sorry, 3 nodes. And let's say that we have a certain number of units coming in here and going out there. And this is A, B, C. And if we had to write this in equation form, we would write then every arc would be a variable, and we would be saying that x AB plus x AC would be equal to 10. And then at this node there would be incoming, outgoing goes positive, incoming is negative, so minus XAB plus XBC would be equal to 0. And at C, this is for node A, so this is at A, this is at B, and at C we would have incoming now minus XAC minus XBC is equal to minus 10. If you look at these, you will realize that these are not independent. In fact, if we add the first two, if we take the equations at you take the equations at A and add to it the equations at B, we're going to get XAC plus XBC is equal to 10, which is exactly the equations at C. So there are really two independent equations with 3 nodes. And if we go back to our if we go back to our diagram here, we then realize that although we have 8 nodes, there are really only 7 independent equations, and that would leave us the 7 basic variables and 3 non-basic variables. And so the algorithm that we will be talking about with which of these arcs, which of the arcs in a particular problem should be basic arcs, basic variables, same thing, and which one should be non-basic.